Hello everyone, welcome to Curated Reality. This episode we are going to talk about health, and we have with us Adit and Adnan.
Hey guys.
Hey everybody.
Hey guys.
Uh, so I think we can start. Before going into health, so should we talk about Dagger a bit because I think we should talk about Dagger, right?
We should, yeah.
Yeah, it would be nice, to just to understand why move to health, right? To be
Right,
honest.
right. So we are assuming that our viewers already know what dependency injection is and why do we need dependency injection. Uh, and if you want us to do a episode on dependency injection, please let us know. Yeah, we can start at it.
All right, cool. Okay, to begin with, all right. So, what is Dagger exactly? Dagger is something that provides you a tool set for Android projects or Java projects that allow you to uh, manage dependencies basically into your modules. You can have a you could have a single repo project, or you could have a multi-module project. Dagger kind of works on both. There's a bit more learning curve with multi-module,
Mhm.
but with Dagger, I think things have improved quite a bit over the last few years. I remember when I started with Dagger, it was like that magic tool which never worked, and there were always these compilation errors. And I don't know. How about your experience, you guys?
Yeah, so I started with Dagger 1. Uh,
Oh,
so
okay,
it does not have that compile safety thing, right? So
Right.
right.
yeah, it always crash at runtime. So yeah, it was a pain.
Yes, yes. So Dagobon was actually based mostly for the Java projects, right?
All right.
Earlier, if
Right.
you recall, we had Android in the Java world, and everything was like kind of tied with the Java principles and software design patterns.
Right, right.
So, and BI was something that was pretty web oriented. It was not something that the mobile engineers would pick up on the first go, unless you're working on a really big app and you need that kind of heavy lift of dependencies. So yeah, but yeah, with Dagger 2, I think a lot of things kind of changed for the Android developers specifically
Right.
because uh, with Dagger 2, not 2.1, Dagger 2, a lot of those scopings, a lot of the compilation benefits from a Gradle task would kick in with Dagger 2. And with Dagger 1, there were a lot of complications. There were a lot of things that you had to do manually,
Right.
and with Dagger
Right.
2, a lot of things just started working out of the box. That was a very interesting year, actually, because the migration guide was not that straightforward, unlike, say, something like RX, where you could just replace a package. Dagger had those complications where if you have designed it in a certain way, your DI structure, a bit of your architecture had to change to kind of adopt to the new one. So yeah,
Right.
that was
Right.
interesting.
I
Yeah.
think Dagger has always been bad in terms of documentation in general, right? Trying to explain. Like
Yeah.
I still remember when I started looking at examples online, and everybody just had that coffee
Coffee
mug and
machine.
the
Yeah.
motor, yeah, coffee machine example, and I'm like, all of that is clear to me, but how is this happening via code? Like, how does the coffee machine is able to produce that coffee to be directly without me having to reference to it? And I think that's where, for most of the people give up there because it seems very magical, right? Like, there is no logical connection to it in terms of, hey, you know what? I just add a couple of things and everything seems to work. And there are places, genuine places where I know people who have tried to do that, and then they are like, nothing, it does not work at all. And then I'm like, you did not even give a implementation for the particular dependency. It's not like black magic, right, that it will just manage to find it on its own.
Right, right. And also the codegen part of it, right? A
Right.
lot of people
Right.
did not know what was actually working in the in the background. Like if I write this
Right.
line of code, how do I connect the dots together? That was tricky for a lot of people. A lot of people. Interesting. All right. So, but then with that also Dagger.Android came out, and I think for me that has been the most interesting bit because a lot of people were against it. A lot of people were using it, but did not know how to connect the dots.
I have
Uh,
I have never looked into it.
I think you're blessed.
I still don't know what Dagger Android does.
So, okay, so Dagger.Android is basically just a framework within Dagger. It was just an extension on top, which would help you kind of bridge for the memory constraints within Android. Like, for
Right.
example, Android applications have a process, correct? It
Right.
has a life cycle.
Mhm.
With Dagger, you had to control the scoping, you had to control the life cycle of a particular dependency,
Right.
and people had to write
Right.
their own scoping.
Yes.
With Dagger.Android, a lot of those kind of shifted paradigm, like where you just write a certain @@ annotation and voila, everything works out of the box.
Okay.
And I mean, it was great for something like where you are using, say, like a Android architecture components.
Mhm.
I mean, if you're using it, combining it with, say, like a simplified architecture, then it worked all great. If you have a more complex architecture where you have, say, something like state machines and everything is contained through an intent or something like that sort. Dagger.Android was a big pain in the butt to kind of work with because it would, again, derive a lot of the thinking based on certain architecture and you had to apply them on whatever architecture you're working. As an example, Dagger.Android mostly works very well with MVVM, that is model view model.
Right.
And if you had something like MVI or MVP even, a lot of those learning curves grew quite a bit with Dagger.Android.
Okay.
Yeah.
Right. Like I'm in the same boat as what Vedant is. Like I have never worked with Dagger Android. Like even after it came out, right? It felt very weird to me that it started talking this Android related language, right? There was something called Android injection, and I was like, why is it trying to do like getting into the Android side of things? Like up until then, if you have worked with Dagger, right, it works, you have a lot of control over it, that when you kill it, when you start it, how many instances and things like that. But then with Dagger Android, when I looked at it, I was like, no, this takes away everything that I have known about Dagger, and it's just like trying to do it magically for me.
I think for a lot of people who have worked on Dagger, right, who did not pick up on Dagger.Android, a lot of things have changed on, say, for example, if we take a very simple example like activity, right?
Right.
You would write a component, you would write a module, you would do all
Right.
your provides and binds, correct?
Right.
You have to do a lot of component level code building, like the builder of the component within the activity code or some class that manages it for you, right?
Right.
And this was tied to the UI layer, correct? With Dagger.Android, we had this fancy thing called Android injection. Basically, it injects, you could say something like, hey, I want this dependency in activity, but I don't want to wire it.
Okay.
Earlier, we had to write the wiring to say, for this activity, this is the component, this, and let's say that you break it down in packages. Like you have one feature, one activity, one
Right.
track. You have to like break it down in everything. Now with Dagger.Android, we had this application class, which was like native to every application, correct? You could write something like this: Dagger provides the wiring for you. You can just say, "Hey, this application will provide for all activity-based injections," and the routing would have been handled by a simple provides function through the component that you write. And all you have to do was in your activity just write Android injection.inject over here, and that's it. So based on the context, if it is an activity, if it is a service, broadcast, whatever, I mean, Dagger.Android bought that kind of fancy tool, like iCandy per se,
Okay.
I would say. We just bought it, and you don't have to write anything. You just do your DI as a separate thing, and you just dump it there. So that is what changed. It is just a way of writing just 3 lines lesser than you would use.
Right.
I would put it 3 lines because you would write the same 3 lines anyways.
Yes.
Yeah, like basically builder.component.inject passing in this.
Right. But yeah, a lot of people would struggle with getting that. Imagine that you had like something like a core common module and you had a lot of dependencies right there and you wanted something in a feature module, correct?
Right.
Or if I don't go the multi-module architecture, let's say if I go multi-package architecture, right? In the package, you wanted something that is there in someone else's package and you just want it delivered to you, right? And what will happen is that you have to write all the wiring all yourself. Like you have to say, hey, core component, this fellow is going to be a sub component, and then you're going to this dependency will go to the component layer, and then component will give you the all those exposed functions. So basically, if you look at Dagger, it's nothing but exposed functions. You say in the that I'll provide it, I'll initialize stuff for you, and you can control the singleton or whatever scoping you want. Like you can control it with a feature scope or runtime based or source time based, correct? And what would happen is that people would have to wire all that. Now with Dagger.Android, all of this kind of came into the picture where you don't have to do any of this. You just write your scoping, you just write your provides, and the application class would say, hey, I will provide it in whatever Android-based framework component you want, like a service, broadcast, and so forth. So that kind of
Right.
but in Google I/O, it finally gave its life, and all of us like literally were shouting, "Yes, finally, something that was because it made developers a bit lazy with Dagger on Android. I feel they didn't really do the scoping well with the .Android extension. I would say people jump too quick into that because if you look at the current usage of Dagger, correct. You would find about like 75% of the developers on GitHub. I'm talking from a GitHub repository perspective. Like 70 to 75% would be using it on Android projects, and have it on a web app or say something like a Java-based project.
Right.
Yeah. So people are still actually using .Android, even though support is dead. You can it as a package, but the support is dead. With that, I mean, I think whatever Google has come out with is like even more impressive, especially with Hilt.
Right.
That's our topic for the day.
Yeah.
I think Hilt has provided the exact amount of the finesse you need for writing DI, whether you're using an Android or not. Hilt kind of brings that DI concepts and puts it in your control instead of it controlling through CodeGen, or I mean, usually we say that term, right? Magic behind the CodeGen.
Right.
Yeah.
You have a little more, at least you know what you're wiring together. So you're also part of it. So that's very interesting.
Okay.
Cool. All right. So with that, I think we can take a look at some of the examples. I think, what do you think?
Yeah, that would be nice.
Sure. All right. So is my screen share live?
Yes, it's live.
Yes.
All right. So over here we are using this amazing example called Pokedex. I think this is one of my most favorite repositories. This has two of my favorite things, Pokemon.
Yeah.
Even I'm a big fan of Pikachu and so forth. But I think this repo really showcases a really good kind of example. And I think this is the recommended. I would say this is my recommended example for Dagger. There are a lot of good things here that the developer has built, man. It's an amazing fleet of showcase of how things should work. So just as an example, before we used to write this application class, correct? With Dagger or Android, you would do something like you would have to write, you would have to do something like, hey, I have this has injector for activity, has injector for fragments and whatnot.
Yes.
Even though this project doesn't have that, we don't have the Dagger. 2.1 is where actually Dagger.Android came. With Hilt, the dependency has changed actually. Let me quickly also jump into that. So if I look at, So we have this like kind of 29 now. Earlier, back in the day, it was like 2.1. So a lot has improved. Even though this is an alpha, I think it'll improve. It'll take about a few more, say, weeks or months. But I think by the time we actually learn this graph of Dagger Hilt, this will already be production ready. And I think this is a better deal than, say, something like Dagger.Android, which is now dead anyways. So all you have to do is basically add these two dependencies. So if you look at, sorry, my bad. Oops, there you go. Sorry. So all you have to do is basically bring down your Hilt dependencies. So basically now what we've done is one more key important thing here is that Dagger has split their those internal dependency graphs. So you have like Hilt Android if you're working for Android. So you can also use Hilt on a Java project. That's very custom and very nice.
Okay.
I also like that you have something called as lifecycle view model. So that means if you're using architecture components, I would say if you are, then Dagger and connecting with view model was a pain back way with Dagger.Android because you have to control all the scoping.
Right.
You have to understand when the view model dies, then the dependency graph of that particular feature should die.
Right.
All the
Right.
common ones that are like scoped as singleton should remain in the in the stack. So with this, I think this gives you a nice little convenience dependency which handles it for you. Also with Hilt compiler, I think things have improved way better.
Mhm.
Even though this is an alpha, I'm kind of impressed with how easy it is to build this, especially with our 16 GB max. It's a bit difficult to get the compilation times under control. So I think this gives you a little bit of kind of an edge. Also,
Okay.
then we also have some testing with Hilt. So,
Okay.
So with that, I think we can quickly jump into something like this. So what we're doing here is we're basically saying that, hey, we have this application class. This is declared in my manifest. I would want this to be controlled by Dagger Hilt now. So whenever this application comes, you manage the state of affairs for all the dependencies that are supposed to be available throughout memory, right? As long as the process is running. So just for context, Android application, when it starts, it's running in a process, and that process is unique as long as the app is in memory. And this Hilt is basically taking advantage of that and controlling whether when this starts, we will control this. So just as sorry, I don't have any slides today. I'm keeping it all, just showing the documentation today.
Yes.
So what we're doing here is basically we're saying whenever the application comes alive, keep this ready as a singleton. So any dependency that you declare with singleton in mind, like if you're scoping with singleton, you can have it initialized when the application on create is called. So as you can notice, all the dependencies that you want with you want it in memory as long as the app process is running. Obviously, you're going to create it as a singleton and you're going to manage the state. We no longer have to say it as singleton. So basically, if you look at the modules, I'll quickly jump into one. So a classic example is like a network module. Very straightforward. You need an OK HTTP client. You need a retrofit that stays in memory as long as you have a network calls to be made. It could be from any screen, right? So what's happening here is that we have a singleton. This remains as is. Nothing has changed in module.
Yes.
The only benefit, the biggest benefit over here is that you don't have to write components anymore. So if you notice, if you look at my DI on the left side,
there's no component.
Right.
Because I'm literally saying, hey, whenever this module is about to be initialized, I want to control when this module is initialized, right? I'm saying basically this installer is coming from the Dagger Hilt dependency. And over here, singleton component is basically saying, hey, whenever this module is initialized, this singleton component is where I want everything to be scoped up to.
Okay.
So everybody scope up. Because the module is always defined in a way where you define all your provides. Basically, you have all your provides, correct? Sorry. So you define all your kind of functions where you're going to provide and binds and whatnot. And at the end of the day, you would write another component and you will bind it all together and so forth. Instead of you writing the code. So now the beauty is you don't have to write a component. Now, you must be thinking, hey, how does it help me? So to break it down, you could say it like, hey, I may have multi-module architecture here. Let's say assets is one.
Right.
There is, I'm just giving it as an example. Let's say assets is a module. I can just declare my module and I can control the scoping of it. I could say, hey, network is part of the core module.
Right.
Core is something that needs to initialize. When I say singleton component, if you follow this graph, basically this is annotating the component level. So if you realize in Dagger, if you don't scope your components, it is by default not a singleton. I think that's a misconception that a lot of people have that, hey, I don't declare anything as a scope and it works as a singleton. It doesn't. It remains as long as there is a requirement for it. So it works like, give me as long as you have, otherwise recreate it because I'm calling for it.
Right.
If there are no one available, if there are no subscribers, like if there is no one, like if let's say, if I am the component and if Vedant and Adnan are asking for a dependency, then I will keep it in memory as long as these two guys are in lifecycle.
Right.
Once these guys kind of step out of their lifecycle and these two guys stop requiring this particular dependency, I will not keep it. So with that, you don't have to think about scoping. That's where Dagger Hilt is really, really powerful because you don't have to write these things. I'm not even naming that, hey, juniors will do this. I think even in my past experience, like a couple of weeks back, I forgot to write a scoping, and we figured it out during production sanity of our project. This is a very simple, straightforward thing. I had written a certain dependency that needed to be initialized during the application, and I forgot to do it singleton. Right. And we got some weird, very weird level of behavior, especially on the production builds. We didn't catch it in debug, and luckily we realized that, hey, scoping is a problem. Now with Dagger Hilt, as you can see here, we have this particular kind of fancy tool set that the annotation processor, the pure power of annotation over here is that when you say, hey, install with, correct? Install in, sorry. You're saying, hey, I want to control the scope of all of these guys with a component which is currently controlled by the application layer. So if the application picks up, that is on create, we will create it. When the application dies due to, say, memory constraints, or if you kill the app or you swipe from recent on few phones, then if you want to swipe it, all the dependencies will immediately die down as well. Right? Okay. And it also opens up the possibility of you doing lazy loading over here. I don't know if people are aware. You can have something like lazy over here from Dagger. And you can have this, I think I have some dependency conflict problems. But you have a lazy, and you can say, hey, I want this scoped only when if there is, say, this much memory, and if there is only one requirement or there's one trigger point. Like, for example, if, say, a view model needs, say, OKHTTP or of something of that kind, only then come make this builder kind of create a new instance and manage it for us, right? So yeah, again, this is the singleton component. So if you look at it from an application perspective, this is a very straightforward, simple, very base project. So what we've done here is we've just written Hilt Android app, and that's it. When we compile this project, it will initialize a network module for us. If you look at other modules that we have, even persistent. So we have like some database over here. So if you've never seen this app, basically what this does is let's pray to the Android Studio gods that Studio doesn't crank up the memory today. But yeah, let's wait for the AVD to come. So what's happening here is that we have a database. Obviously, I need it initialized, but not. And we are basically based out of Room in this project. We want access to this instance. Whenever we would need, whenever we could, access through a feature. At the same time, we are also having some DAO. DAOs are basically data access objects. So if you've never used Room,
right?
And we've all declared this a singleton. So this doesn't mean that the database operation is open. It just means that the access points are available to you in very plain English. Like these are, this is what you call to kind of say, hey, this is the query I want to run, and then it opens the database SQL operation for you. By the time the emulator starts, what we'll do is we'll also look at the repository module. Now, you might notice one thing here. If I can split this. Oops, sorry.
Split vertically.
Yeah, this is something that I always go with. I do the horizontal first, and then I make my mistake. Yeah. Okay, so if you notice, see, repository is something that I want to keep alive. Like I have something. So we are following the repository pattern here. Right. Basically, repository is doing the business logic. You can think of it like all the network is talking to a DB. Should I do it or not? Right. Don't worry about the coroutines here. This is just the core of the functionality. Right.
Yeah.
And what we see here is that repository is something that needs to be initialized upfront. Right? Because this application has two primary screens. You have a list page, like a grid format, where you can see all the Pokemons. And if you click on one, you are taken to a details page where you can then interact with the UI to see more details. Like it could be what are the trainers, what are the skill sets, and so forth. So there are a lot of things that you can build. And instead of building two repositories, over here, we have chosen to kind of go with main. And there's another thing called detail. So it should be in a way that both of these are basically just doing few things. If you look at detail repository, basically this is getting the details and so forth. So it's nothing too complex. And again, the persistence module is basically for database shared preferences, maybe, if you have something of that kind. The difference here that I wanted to highlight again was, sorry, if I go back here, this particular module is currently recommended, we are recommending that, hey, this should be initialized with an activity retained component.
Right.
Meaning, if an activity comes, so we are using like a architecture components here in this project, but if you're not, you can also design it with MVP in mind.
Right.
Just that you will have to write a lifecycle based observer. If you've used Android architecture components lifecycle owner, there are these overridden functions through that interface that you can implement in an object class if
Right.
you're using Kotlin,
Right.
or some kind of like a regular class where you can do your operations on. So if you don't have view model, so over here we're taking advantage of something called as a view model. If you take a look at, we are using something called as a view model. We are using coroutines as well, but if you realize how view model works, this is very important here, right? When the view model comes up, correct? This is initialized when the activity is about to start. So if you realize how
Right.
if you've never used view model before, sorry, I'm just jumping just a tiny bit into it. So if you look at, we give lifecycle owner, correct? We basically every activity, every fragment has a sort of a lifecycle that we anyway know. And with the Android architecture components now, what's happened is that you also have control over those on stop, on pause methods, and you can write some dependency based magic with it. So instead of you writing it now, Hilt has provided you that functionality. So just to see this, if you look at the view model, correct? So we are using a kind of a binding logic here. We are using a view binding. That's why you will not see much of this. If you look at this VM instance, oops, sorry. I go back to, oh, sorry. Okay, one sec. Sorry. So over here, when you initialize a view model, sorry, we don't have that example right now. You would initialize the constructor of a view model. Basically, you have to initialize the view model, right?
Right.
So we need some dependency, and we also give it another thing called some state handle. I'll come back to this particular part. But if you realize the regular view model, you also give a lifecycle owner. Basically, you say, hey, view model initialize, but with this activity or with this lifecycle.
Right.
Scoped it to that lifecycle component.
Correct. So now the reason I'm kind of jumping into this particular flow is because this is very important. Now, what this does is when the activity comes alive, view model will also be requested for it, because if you look at this example, this is where we're saying, hey, this view model is what I want.
Yes.
So if you look at this particular functionality, so over here, what we're doing is, if I expand this out, sorry. Yeah. If I expand this out, so we're also doing a lazy initialization over here. So if you look at this lazy, this is coming from the Kotlin lazy. This is not the Dagger initialization. Right. This is basically just saying, hey, I have a view model. I don't know the, I can't infer the type of it. I can't infer the instance type of it. I have a very basic thing called VM, right? And VM is nothing but a view model. It's an extension of the view model, right? Now, what this guy does, it takes the current activity or whatever you pass. Like over here, we are basically, when you say component activity is giving the this or the context in which you get the lifecycle owner. Now, what this guy does is, it takes this. It's a really fancy extension. We have inlined it as well, so that we don't have to create MP for it. What we're doing here is we're initializing this particular view model with all its dependency, and we're also utilizing the Dagger's provided assistance. I'll come to what assistance here is. Now, what this does is it initializes the view model for you, and only when a view model is requested for. So imagine that if I write something like view model dot say fetch something, correct? Right. If I do something like that, is when the view model will get initialized. That's all this particular extension function is all about, right? Also, at the same time, when this guy is coming, so we are literally saying, hey, activity is the lifecycle that we're going to start with, and view model is where we are going to attach the activity's lifecycle owner. Now, even though I've jumped into Android components right now, but if you look at it, if you come back to the repository module, this is what we want, right? We want this particular main repository and detailed repository when that particular scope comes, correct? And we also have this fancy thing called activity retained scope. So literally, if you read it in a very plain English, it says, as long as the activity is alive, all the dependencies that it needs should be alive, correct? It's a very simple, straightforward thing. Right. If I quickly just jump into over here, if you look at this particular functionality, activity retained component, so this is basically saying, hey, if you're using this particular component with the install in, you also have to kind of adhere to this rule called you have to bring the scope of activity retained scope. So if I just quickly just jump into persistence over here for a second, if you realize I had done singleton component,
Yes.
install it, I can't write something like activity retain. This will not compile. So you'll have a compile time error, basically. It'll not even give you those. Okay, Studio has some weird. It's not giving me any. All right, no problem. Yeah, okay. So you can't really crossfire things. So basically, Dagger Hilt is giving you the control, but also telling you that, hey, since you didn't know how to build scoping for this, why not I show you how to do it? And if you are using Hilt, you don't need to use Hilt, by the way.
Right.
Sorry, as a disclaimer, you don't need to use Hilt. But if you're one of those brave folks who don't want to manage scoping, you can follow something of this kind. So with activity retained component and also the retained scope, what it does is whenever the activity on create is called, correct? To start the view model. So we're not initializing the view model ourselves. We are using something called view model lazy.
Right.
This is coming from the Android X lifecycle component. So you realize there are three things that I want to highlight here. It takes a view model class, obviously the class that you're currently using for your functions. It uses a view model store. Nothing very fancy here. I will not jump into this. And a factory is a factory pattern to generate the view model constructor. Right. If you realize that, if you look at this guy, there is no constructor. There are no constructor params, and we as consumers of these classes would not have control over how to initialize. Sorry, not this guy. Yeah, you will not have the control over how to initialize this particular constructor. Now, what we're doing here is essentially saying, I want to bring this thing called view model inject. Now, view model inject is coming from the Android Hilt dependency. Like I said before, we have those lifecycle dependency graph, right? Sorry, there we go. So we had this guy, right? Lifecycle view model. So basically, this is what is giving us this component called, if you look at this view model inject, this is what is giving us this fancy tool that controls the target, controls the retention, and also figures out how to generate the graph path, or basically the cyclic graph for the Dagger.
Right.
Now, so we will not dwell into what this function does. Basically, this goes and fetches stuff. And if you realize there's this fancy thing called @main thread. This is coming from Android X support library. And what this does is basically this is just calling the live data and saying, hey, this is the value. That's it.
Okay.
So basically what this guy is doing is that whenever this guy is getting a new value, this guy goes and basically gets, there's some page number. That is what you get here.
Right.
And we have written this in an initialize block. This is a Kotlin initialize block. What this does is it basically starts a coroutine for you. We are starting the coroutine in main thread and switching over to a background thread to do network operation.
Right.
So without jumping into the feature sets, if I go back into the main activity, so if you realize that it's a very straightforward approach now. I want a view model. I need some repository. Repository needs some retrofit and all that. I have not written a single line of component layer.
Yes.
The only magic is these three things: a network module, a persistent module on your right, a repository module which initializes everything. Sorry. Correct?
Yes.
Now, if you look at this, there are a few other things that you can also control. You can also have an activity component. Basically, what this does is, as long as the activity is in foreground, keep this in memory. So there's a bit of a kind of a stance here. If you look at activity scope, so basically, if you realize retained is basically so you have like an activity stack, correct? Now, activity stack would remain. Let's say that you start an activity A, you go to activity B. A goes into kind of a pause state, and B comes live. B is an on regime, on create, on start, whatever, right?
Right.
Now, activity component, if you have declared some dependencies, if you have created a module specifically for that activity, like a very classic example is like you're building a chat message activity, where you're typing the screen where you type your chat messages.
Right.
You want to initialize the emoji library only in that screen, and the entire app doesn't need the emoji library.
Yes.
As an example, you can keep this only for that activity. You can also scope it only for that fragment.
Okay.
Right. And now what will happen is whenever the fragment attaches or whenever this activity creates, all the dependencies that are there in this component. So basically, if you realize the Dagger or DI thinking, a component is what wires, they provide functions and exposes those functions and gives you those dependencies, correct?
Yep.
So if someone requests, I want main repository, the wiring is coming from the component that is currently controlling it, and the module knows how to initialize stuff. Correct? Now, with this activity component, you're just saying, hey, all the guys that have this scope, correct, will initialize only when this activity comes. So basically, if you realize a lot of these, like as your source code increases, correct, you will come across a very common pattern where you have a lot of things to be initialized in the common module. You have a lot of singletons, and just imagine you have like 4 things that you have to initialize at start.
Right.
If you don't use application will become super heavy. Your splash screen, even though you have like a 1 second timer set for it, you will actually see a kind of a bad effect of initializing a lot of things. Because when the application starts, there's a lot of stack to start initializing with, correct? But if you have something designed in like a scope manner, that is why scope in Dagger is very important. If you have some kind of a design like this, you can say this library is not required right now. Emoji, I only use, as a developer, I only need it in the messaging activity. I don't need it across the project.
Right.
So if you have something like this, it's very well defined and it is controlled. And same with Vue. With Hilt, actually, a lot of developers actually don't use fragment. So I am one of those guys who kind of hate the concept of fragment. I don't know why they exist, but I build mostly custom views and control states with finite state machines, and the view will only respond to a single state, whatever I emit as. Correct? So I have some control over it, and we can kind of achieve similar behavior as a fragment within a custom view. So basically, for folks who don't know what a custom view is, I'm basically extending a view like a view group, like linear layouts, relative constraint, whatnot. Or I have a regular class which basically initializes kind of and inflates a view within a certain viewport. That's it, and nothing very super different. Now, this is super important for folks who use Vue. This super call is basically when the view is created, correct? So when the view is created, I want some dependency like drawables or like Lottie files. I can actually, like if you use Lottie, for folks who don't know Lottie, Lottie is an animation library that loads a JSON, decrypts it into an animation view. So it gets rendered on a custom image view that is built by Lottie image view. Right? That's the wrapper on top of an image view. Right. It's an engine basically which renders the JSON animation. Basically, the exported file is a JSON. It converts that into frames and then runs it on that view. Now with the super, I can build custom animations and bring dependency injection. Like for example, if I have a dependency of say, like a view model that needs to first call the data. Once the data is ready, then initialize the view. I can do that. So you can have something like if you take a very simple example, you have 3 like primary use cases in a Android application. There's a loading state, right? There could be a data state where you are actually showing the content to the user, and then there is an error state. 3 classic examples. I can have 3 different views. When the loading is coming, I don't need the Lottie view to be initialized. When the data is ready, I just at the tip of this super, I will call, hey, initialize this fellow, where the Lottie view is coming, and there's some image view that I need to show an animation of sort. Like let's say some text, there is some Lottie view. A lot of people might have used these fancy apps called Cred and a lot of these Paytm and even Google Pay, for example. A lot of these animations that you show with your content. Instead of loading everything in memory upfront, I can have this view.super can initialize certain provides. So that's really very interesting, right? Now, all of this, what do you guys think? Like, is it more easier compared to since you have never used it?
I have one question though. So,
yeah, sure.
Can we create our own scope? For example, I have a module like onboarding module, right? Splash screen will be there, then login screen will be there, and I want some dependency to be live in that particular time. So can we create a custom scope?
Yes, you can. So basically, see, when I say activity retained component, right? If you look at the depth of it, if you look at this again, so this class is basically on the class that you're currently injecting it in, right?
Right.
So there are 2 sides of this question, right? One is, hey, which component will this adhere to? What rule will it adhere to? Right. And this dependency could be something like, hey, my custom feature scope.
Right.
Correct? Sorry.
Exactly.
Right.
You can still have this because this guy is going to be controlling. So if you realize in Dagger, right, the component layer, even if you have unscoped bindings, So imagine, sorry, if I write this quickly, sorry, whatever. Yeah. So if I have something, just as an example, right, to your question, sample component. I'm following the basic, what do you say, the Dagger. I'm not doing any custom things
Yes.
here,
Yeah.
right? So if I have, okay, let's keep it as an interface itself, right? So obviously I'm going to have like a component of something, correct? So you still have this, correct?
Yes.
And when you say module, obviously you're going to give like something
Right.
like, okay, I'll use repository itself,
Yeah.
because repository is more common to use case that you would
Right.
initially,
Yeah.
right? Right?
Correct.
Now, if you realize I have not scoped this, correct?
Yes.
I have
Yes.
not
Right.
written anything. What happens is, because sample component, so imagine that, let's say, sorry, let me squeeze this one out for ease of the viewers. Let's say I have another interface, correct? Subsample. Subsample is just another thing that is, or okay, just for the convenience of things, let's call it co-component. This is what you would do, correct?
Yes.
Right.
And also, just as a pro tip, do not use subcomponent because when you declare a subcomponent, like if you have something like this, correct, and you will obviously going to give, sorry, I've forgotten, since long I've not used this, dependency, sorry, just give me a second, modules, okay, fine. So when you say this subcomponent, right, you're just declaring this much, you're going to say, hey, I'm going to depend on this fellow,
Right.
Right.
correct? You're going to say, hey, I have this pure fellow who will provide me something like this. So imagine, so I'm writing all of this over here for convenience. Let's say I have core module, correct?
Right.
In this, I have some provides singleton, correct? Sorry, for the love of God, I have my shift key pressed wrong all the time. Okay, so you would have something like, say, provides really heavy initialized object,
Right.
correct?
Yes.
And for some reason, I'm writing a thread sleep just to show you that, hey, this takes a bit of time to kind of initialize. Let's say I put 1,000, right?
Yep.
And I return something over here. Let's say I return a, do we have some fancy class here? Okay, never mind. I'll just create, right? So I will return, I'll write the, for some reason, I like doing this. I don't want to write this colon and all that, right? Okay, so usually this is what we used to do, right? We used to do this in the regular Dagger where you have this. And because you have written a singleton here, core module, I'll come to your point.
Got it.
So the point I'm showing here is that subcomponent would know everything about the component. So
Yes.
if you had to expose this, so if you realize, when I say core component, right? And I'm obviously going to give a repository module, and this core component, obviously this modules is equal to, and obviously I'm going to give the core because,
Core.
so basically this is what is breaking it apart.
Yes.
Right.
Sorry. This is what is breaking it apart. Correct. This is where the core initializes, and this is where the feature class is.
Right.
Correct? Now, obviously, this fellow is like something that you would use in your activities. Correct. Now, if you realize in the core component, I'm not exposed to anything. So if I ever want to get this, I can only do an @ inject. I can't really expose this out of the box. But if I write something like this, fun, all I have to do is example object.
Yes.
Okay, short form.
Right.
And I have to get the instance of it.
Yes.
Like basically, I have to expose this out. That's when you can then, anyone who, like, let's say you have another of this guy, correct? Again, I'm just using the same module, just sampled, right? Now, if I don't depend on this, I can still access this only for those who are having a singleton scoping.
Right.
Now, the problem that I wanted to bring, so I'm kind of pointing to two things here. If you don't scope it, like if you don't scope it to, say, singleton, sorry. Oops, sorry, I've forgotten how to type. Yeah. So if you don't have this, basically, your Dagger component cannot access it.
Yes.
Correct.
Because the graph says, hey, core is there. It's basically a subcomponent. Anyone who depends on it, let's say I don't do this fellow, right? And I don't even have this. This guy for some reason needs that exposure. Let's say this is feature 2, correct? This is a separate module. We don't have direct access to this thing called core component. We don't have access to that class. So if you have something like this, you probably can't access that functionality. But because Dagger is compatible across multi-module, when the app layer is compiled, app depends on a feature, correct? So you have like app that has feature, and feature has other things requiring that is required over there, right? Now, app when it initializes, obviously it notes that feature 1 is there, feature 2 is there, and because of that, the Dagger tree is then generated, correct? If you realize when you build, Dagger takes a bit of a compilation time from the annotation processor. So when you do this, you will have problems to access any of these things called example object or whatever else we have initialized here. Now, if you ask me like, hey, can I scope this? Let's say I've written for the time-based thing, I'll just quickly go over. I'm just picking one of this scope classes just for the generation. Right? Let's say I have my feature.
Correct.
Right? And instead of this, I'll say runtime. So coming to your question, Vedant. So when you say this kind of thing, right? You don't have to scope your component, but because I have repository module, let's say I have something else over here, correct? Oh, sorry, my feature, correct? I can say provide. I'm just taking another class object here, just for the sake of it. Okay, let's call it Hilt object or Hilton Hotel object, just to keep it in the loop, right? So let's say I provide provides Hilton. So this is a custom scope. This is what you were asking, right? Vedant? This is something that you don't want to be. You want to control the custom, or rather, you want to control it in a custom fashion. You don't want it to be exposed outside, right? So when you do this, I have no dependency for it. All I will say is return Hilton object, correct? Then obviously return, Now, when you have this, if you realize the object or this module is saying that I'm going to install myself into a component that is controlled by a retain component, correct? If you copy the same thing, so if I bring it outside, never mind. So if I do something like over here in the, where did it go? Sample 2, over here, instead of this, correct? Oh, sorry. Let's call it sample 2 module. So basically, this is what you write, right? You write a module, you write a component of it, correct?
Yes.
Obviously, with a module. Oops, sorry. Please, you would do something like this, correct? And this is a regular Dagger, right? We are not doing anything sort of held. When you do this, my feature is the only scope that this 2 things will control. Because this component has no scoping. So as long as this fellow depends on something else, let's say now this fellow depends on that thing called subcomponent, called core, correct? So sorry, if I do this. So I'm not talking about Hilt over here. I'm just very simply just putting it in this format that this subcomponent is also not scoped. Basically think of it like an inheritance. Because this core module only has 1 provides. Imagine that you don't do this, then you're screwed. Because as long as there is one guy, this is what I was explaining before. As long as there is an activity, if you have I'm just writing, just as an example, my activity, correct? It's not a regular Android activity. It's just for an example. You have something like this. Correct? And if you look at this, we have an example object. Right? Okay, I'll just call it this. Correct? This is what you would do.
Correct.
For what joy reason is latent. Sorry, my bad. Okay. Now what will happen is, as long as we are not controlling the scope, as long as this activity is calling, because this guy is injecting this guy will get initialized. There's no one else currently accessing it. Now the problem of scoping is, what I've done here is, let me reiterate the problem. I have no scoping in the module. I have no scoping on the core component. I'm only talking about core right now, right? What will happen is when this fellow injects, correct? As long as this fellow is using, it will be there in memory. But for some reason, if main activity dies or if it leaks memory, this object will not be garbage collected. you're not actually benefiting from Dagger in any way. So the point of having DI is that you don't manage state of affairs for the object. Right?
All right.
Now this fellow might leak into your memory, and this fellow will not get garbage collected until there is a bigger call saying, "Hey system, your system says, hey app, you have way too less memory.
Yeah.
Please let me clean some stuff out." That's when this guy gets garbage collected out. That's the problem. But if you scope it, I mean, again, singleton is just a way to say things. Let's say I do it with my feature. This is an example. Now, again, I'm iterating over this. Again, there is no scope over here in the component. Now, when I call this fellow, as long as my feature is running. So if you realize my feature is, where did it go? Sorry. Yeah, here. My feature is basically runtime based.
Right.
Whoever accesses it for the very first time, based on that fellow's runtime, we are accessing it. So basically now you realize, if you look at it just from this example, right, you have no understanding. So just by looking at it, Vedant and Adnan, I have a question. Do you know which runtime is this talking about? So only if, let's say I create another class, just as an example, right? Activity 2. I'll do the same thing. I'll just inject it. I need the same fellow again.
Right.
Now, which runtime scope would it follow? So if you realize, let me bring this up for clarity. I'll move this example down. Now, which runtime do you think this will adopt to? It's very difficult to ascertain at first, correct?
Right.
Like just by looking at a Dagger, even if you're like pretty good at Dagger, just by looking at it, you may have some side effects of this.
Right.
Now, what's actually happening is, if you look at this runtime, the runtime thing, annotations to be recorded in a class file by the compiler. So when this code got compiled, when this got attached to the core module, none of this got initialized. But because it's a subcomponent, and if this, let's say if this thing called subcomponent, core component is initialized in something called as a sample component, and if sample is initialized as a singleton, then this behaves as a singleton, even though my scoping is runtime. That's the problem of scoping in Dagger. Like, you have to be very careful of where you're doing. Now, if I take you back here, sorry, I'll just come over here. Now, with Hilt, you don't have to worry about it. So basically, this nice little table that we're seeing here, basically this makes sure that you adhere to that ruling. And to coming to the Vedant's question, now, if you look at the, sorry, where did I, yeah. Even if you look at core functionality, right? And I'll make this component, for example, right? Now, this fellow is basically the example object, and I want it to be controlled only when I want it. I don't want it to be initialized at starting. I don't want anything, and I'll remove all these dependencies just for the sake of argument, right? Correct. Now, let's say this is where I'm doing it. Let's say this is where. Sorry, yeah. Okay. This example is bad now. Sorry, my bad. This module is no longer needed. Correct.
Yep.
Now, when this sample2 component comes, just for this fellow, I want this dependency. Correct? Just for this particular instance, I want this. See, because Vedant, if I got your question right, you're in a particular feature or you're a particular activity, and you only want that scope to be available to.
Not inside that feature, there can be multiple activities. For example,
like scoping.
Yeah, I have a repository.
Level.
Yes, I have a repository.
I want a common repository across this feature, right? Like onboarding, let's say, makes 4 API calls and 4 different endpoints. But then I have written just one repository, and these are split across 4 different screens as well. And I just want to have one single instance and scope to only that. Like, once he's done the onboarding, I know I'll never use this back again.
Yes.
Okay, so something like this. I'm just writing it for the sake of argument, right?
Right.
Oh, sorry, not this. My bad. Sorry, I had to go to this main repository. My bad. Yeah, I'm just writing it over here. Sorry, I'm chunking the entire code base. I wish I could do this in prod. Okay, repo, just for shortness, right? And let's say I have some functionality internally, right? Some pseudocode, right?
Yeah.
Now you want this to be scoped only for a certain periodic usage only. I say periodic for a very specific reason. Periodic because only when that activity comes in that period of time you're going to use it. Correct? And it could be it could be activity, it could be activity C, it could be activity D.
Right.
Maybe not for B. Yeah. So let's say that sample2 component, this is pre-Hilt. For sample2 component, you had to do all of this kind of, I would say, the Indian word, the jugaad.
Yes.
And you had to then write you again had to expose this.
Yes.
So if you realize, even though we have exposed this over here in core, because it's a dependency, this is like inherited over here. But just because you need to access it in an activity, you have to rewire a lot of things.
Yes.
This is not necessary, but this is just for testing strategy. Like if you write a test case for your components, I would highly recommend people to also test your DI graph, because you don't know what would happen given, say, certain conditions. So you can actually test it in your unit testing, right? So I'm still going to expose. So basically what this function does, for people who don't know what Dagger, this function does is, this takes whatever the provide function is, it looks at the return type, it's an example object, and exposes it. So anyone can say, I can do this at the rate inject. That's how I'm getting this functionality out. Correct?
Yeah.
So when I say out, it's basically the guys who are actually consuming it. Right? And if you look at sample 2 again, this is where we are currently focusing on. So if you have, so with Vedant's question, yes, you can have my feature here, and this can only be available as long as, so whatever you declare my feature as, runtime, correct?
Right.
As long as there is someone requiring for it, it will remain in memory. So you can still do this. And let's say activity 1, or in this case, my activity and my activity, okay, I'll just copy this again. Let's say my activity 3 doesn't need it.
Okay.
It needs, say, something else, like, right, built-in object, correct? Now, activity 2 and activity 1, let's say that the user comes to main activity, my activity, this object is initialized, it's going to remain within memory. Now, when this fellow jumps, say, by button click, I'm taking very simple examples here, he starts main activity 2. My activity's reference is no longer necessary. Only my activity 2 is what is accessing this guy called example object. It's going to still remain in the scope, correct? Now, as soon as this, let's say that this guy starts activity 3, correct? And if this guy is on pause and it's not on destroy, you will have to write. So I'm not talking about Hilt. You have to write a lot of those DI magic. You would have to do a lot of this on destroy kind of thing where you have to destroy all these things. And with Dagger Android, again, Android Inject would handle it for you. But again, it is a pain to kind of work with when it comes to, say, something like a very complex. Oh, sorry. What am I doing? I'm not extending activity. Sorry, my bad. Yeah. Now I'll get this on destroy. Yeah. So basically, you have to like handle this management over here, correct?
Yes.
Okay, let's make it app compact. Nowadays, Android development is like really fun, really painful. Yeah. So something like this, correct? You would have to then say Dagger dot whatever deinitialize and stuff. You have to do a lot of cleanup yourself.
Correct.
Instead, let's say if I take Hilt example here, main activity 3, right? Now, when I bring the Hilt kind of concept, if I kind of drag and drop, sorry, I just want to save. So when I say this particular thing, so this is the kind of the final, the nail in the coffin. Android entity point is basically saying this class. See, because for Dagger, it doesn't understand what Android app activity is or what a service is and so forth. Don't worry about this. Just think of it as an app compact, correct? Over here, we're using data binding in this example. Now, what would happen is that Dagger, we have to write something like this, correct? We have to write something like this for Android injection. This is the Dagger.Android packaging. Correct? We have to write something about inject, blah, blah, blah. And that is how you would get all the injects happening here and so forth. Correct? Now, with Hilt, you're basically saying this entry point is going to be controlled by Dagger. When this activity comes, all the dependencies that this fellow needs, it will be initialized, or if it is already initialized, it will be provided for. You don't have to do anything. Just sit back, relax, wait for Gradle to compile. That's it. Whenever this activity runs, it will basically then ask Dagger, hey, do you have this particular dependency in memory? It says yes, it will give you. If it doesn't, it will initialize based on the scoping. And you don't have to write in.
Okay, so for example, suppose this is our splash screen, right? So we need to do a login check in our splash screen, and then we will go to the next screen, maybe login screen or sign up screen. So as soon as this activity destroys, that component will be cleared from memory.
Okay, so as soon as could you repeat the last part? As soon as,
for example, we want to destroy the splash screen, right?
Okay. Okay. In that sense, yes. So if you again, you can break it down into two things. Sorry, there was a sample component. Yeah. If you don't have a scope on your component itself, like something like that, it's not necessary. It's better to manage the behavior of this. So obviously I will not write my feature or see the way you design. So also there is a pro tip: do not create like some 10,000 scopes. All you can do is use certain things. So if I do this guy, sorry, not on this, on sample 2, because we are currently controlling all the behavior here. If you do something like this, and if let's say activity, I'll just rename this for the sake of it, correct? Sorry, splash activity, right? Now, if this guy dies, your question is like, if this guy dies, will the component also die? Yes. If there's no one else who requires it, if no one else needs it, there's no point of keeping sample 2 in memory.
No, but I want that component in the second screen, right?
Oh, then even so. When you if you take a look at how annotation processing works, right? If main activity, so in this example, let's say this is our main. Okay, let's call it home activity. The same guy is needed again, correct? Literally over here.
Yes.
Sorry. In these two classes, correct? Right. This is also an activity. Let's extend it just for the sake of argument. Correct. Now, this fellow, when it comes, this guy is also accessing the same thing. Then obviously the component will remain because the component, when it compiles, it's actually drawing the graph for you. So these are called, I think, the cyclic graphs. Basically, it determines which dependency is required in which class. Because when you're compiling the code, obviously this code is already there in the code, correct? That is how the Dagger is working its magic. So this guy sees scope is, sorry, the scope is the wrong word, that these two classes are accessing this particular instance, and this guy is provided by this Dagger component. It will keep it in memory. And this will only initialize when this guy comes into picture. So imagine that I'm not using Dagger Hilt, and I would write on it. And I would do something like the Dagger.Android just for the convenience. Right. Say Dagger inject, just short forms, correct? Into this, or what? Dot inject with this, correct?
Right.
Now, what Android inject did was it would take into account that hey, this class is no longer runtime, meaning it's no longer running, and it will destroy based on some predetermined magic behind, or rather predetermined algorithms written for the Dagger.Android.
Right.
Now, because this class is requiring example object, let's say dependency, this is a dependency, and even it requires the same thing. I'll also copy it here for the sake of our, correct? This is the Dagger.Android example, correct? Now, we don't have to do anything. We had to just write this much of code, and we didn't need to do anything. We just inject and get this initialized, correct? Now, what will happen is that because these two guys are requesting for it, during compile time, it sees, oh, okay, this is where this inject is connected. So it basically wires it along, and it will keep it in memory. So as long as splash is there, it will start the instance. So basically, the component will come alive. The module will provide the example object, will remain free, and so forth. Splash dice, it sees, oh wait, home activity also needs it. Maybe someone else might come in the future, and I'll keep it. As long as that statement is true, it will keep it in memory. As soon as home activity dies, it will destroy everything.
Okay.
If these two classes that are highlighted, if it dies, the component dies. Right? And again, I'm reiterating this point because if you have not, so in my example, there is a sample 2, because I've given my feature, correct? So you can control the my feature scoping based on this criteria. I need this in A, B, and D activity, not C. I just want it in D.
Right.
So if A, B are still in memory, it will remain. If D comes after the fact that A and B are dead and B started C, C started D, A and B are not in the picture, C will not initialize this dependency graph, this particular branch of the dependency tree, correct? This branch will remain inactive, or it will not be in. Because D comes alive, again, that moment, that dependency will be available to you. So a lot of people don't realize a lot of the startup time problems, a lot of activity being slow is because you're not initializing your scoping properly. Like you can have a component for your, like let's say activity D has say 5 dependencies that it needs. Maybe you can optimize it. Maybe there are 3 things that are singleton. One thing you need right away at the initialize, and one thing you need when a button click occurs. Just an example. You can have that scope lazy loaded.
Okay, so what happens if activity C never comes in that flow? It will keep that component in the memory for the entire lifetime of the application?
In your question, does activity C depend on a dependency that the component provides?
For example,
okay, let's come back here. Right?
No, I think what he's trying to say is this, right? A, B, and D require it. The flow was A to B, B to C, and C to D.
Yes.
Okay.
Right.
And then A and B are dead now because I'm in C at this point of time. But let's say you never start C. There was a navigational branch which the user could take, and you could go to E directly by skipping C and D altogether. At this point of time, since at compile time, when the graph was generated, basically at startup, the Dagger knows that D is going to
Yes.
require this,
Yes.
and our assumption was that it will stay in memory, right? So what if you never initialize D? Will it still stay in memory?
If you never initialize, there is nothing in memory, first of all, correct? So, meaning, if A and B was completely bypassed, there was no one who
No, let's say
initialized that.
A and B, A and B was started.
Oh,
But
okay,
then,
okay, got it, got it.
yeah, D was never started, which
Right.
and D had the same dependency A and B had. At this point, what happens is what
Yeah,
you're telling.
so if B dies, the scope will kill it. Basically, it knows how to initialize. So, see, think of it this way. If you create a tree graph, so if I show you, let me just show you one sec. Sorry. I'm just trying to. Okay, really? I mean, the day-to-day operations of. So, see, I'm just trying to open a kind of a tree chart. Don't worry about all this.
Yeah.
So, imagine that node 7, 8, 9, 10, 11. Just an example. Sorry, guys, if I don't have a slide today. Let's say 7 is your activity D, correct?
Yes, yes.
And
Correct.
7 also. So, let's just look at the first row 1, 2, and 7, correct? There is no 3 and all.
Yep.
1 and 2 needs something called hintel, but 7 also needs it, but there is no one who connects the bridge. If 2 dies, this branch is dead. Imagine this blue becomes gray. There is no one else in the memory. There is nothing. So whatever this node 1 and 2 requested, and if there is no one else requesting for it right now in runtime, it will die. The reason I say this is because the way you write a scope is important. So basically, when runtimes, that's why I asked you the question earlier. If it is a runtime based scope for my dependency, if 1 is running, great, it will remain in memory, the example object. 2 requires again, 2 comes almost immediately, it will remain in the memory. If both 1 and 2 die, then it's the end of story for it. When 7 comes, it will reinitialize. That is what I was trying to point. 7 will try to reinitialize it. Or rather, the parent component of 7 will try to reinitialize it. In this example, parent component is nothing but our sample 2 component. Basically, sample 2 component will again start its life cycle again. That's the whole beauty
But then if I scope it at a singleton level, then it will stay across, right? It does not matter. The runtime scope is pointless at this point of time. Then let's, for the sake of argument as well, right? Node 1 and 2, as you said, right? If both of them are dead, then the dependency will be dead as well, is what we discussed. So let's say a very unrealistic use case, but the idea is I kill node 1 manually and then start node 2. So at that point of time, right, when node 1 was killed and node 2 was not started yet for whatever reason, then at that point of time, the component would have still been killed, right?
No, there's a bit of a delay of it. So it's not like see, with Java, right? It's not like you'll have a nice little sine wave, right? Where you have like a rectangle shape. It'll take a bit of a peak time to even de-initialize component. So component is still going to stay back. It's just going to say, hey, there is no one who's going to require this. Should I destroy it or not? That particular flow is controlled by Dagger itself. It sees, oh, the scope of this component is not there. I'll keep it as long as there is no garbage collection. That is where this problem statement comes. If you realize, if I remove this, so I'm coming back to my studio code, interface sample to component. If I remove this, and this scenario occurs where 1 comes alive, it requested component, module, dependency, everything is in memory. But 1 died but did not start 2. Or there is a bit of a few milliseconds of time before the 2 starts, correct? 2 will take the benefit of this being non-scoped. Because unscoped components will still remain in memory as long as there is someone who's going to require it. Because if you realize there are 2 sets of things, a compile time graph and a runtime graph. A runtime graph is basic. See, this is a compile time, what I'm showing here. Just as an example, this is not an exact Dagger graph. 1, 2 is basically the compile time. 7 also requires the same dependency. Let's say node 0 was that example object. Correct? Now, at runtime, if 1 dies, 2 is still starting its process, correct? It already knows that, hey, 2 will require it. So component will still remain. That's the whole idea of it. Now, all this we have discussed, right? All of this is still hearsay, thearsay, and within your team, you could have some guy kind of having some kind of a thinking. You could have some kind of another understanding. And there's always going to be like a clash of thoughts. Obviously, we're going to write a proper tested code. we're going to debate, we're going to write tests around this, we're going to run this and see if you've never used profilers here, you can run the profiler and see how the memory spikes are. You can also look at how the objects are initialized and so forth, correct? A little advanced there.
Yeah.
But if you use something like this, if you use something like Hilt, you don't have to worry about scoping. All you have to do is make sure your dependencies are properly scoped. So if I take that example back here, if I come back here, if I take this fellow back again, correct?
Yeah.
Now this guy is initialized in something called activity retain component. So if there are 3 activities, there are 4 activities, 5 activities using this, all of them will require this fellow. And these are not singletons. If you realize, these are not singletons.
Right.
I want this retain as long as main. So basically there's a screen. Sorry, we haven't even shown the app. My bad. But yeah, welcome to. Sorry. Yeah. Okay. Let me see if I have Jenny Motion. Just for the. If people who have never seen Pokemon Dex as an app, I'll go to. So basically, there's a list page and there's a details page. In the list page, I want the main app repository. The same requirement is not needed in, say, something like. So if you realize, I just want, like, if you look at the view model, sorry, let me go back to view model. Main view model only requires main repository as long as the main activity is running. So if you realize, when I go from list page to details page, there is not much, like it just goes into on pause. It doesn't get destroyed. So that main repository is still in memory. Right? And if you look at this details view model, again, this guy just needs a detailed repository. There is no like cross requirement of this view model requiring something called main repository. So there is absolutely no need of it. So sorry, if Jenny Motion can quickly boot up. All right. So the beauty of all of this is that you are just saying, hey, this is the entry point. This is where I'm going to inject stuff. Correct? So if I write this in a more, so we are using data binding, but if I write it in a more regular, format, you would do something like this. Late init VM, just so that I can get that nice little. Oh, sorry. Now, as soon as I write this and when this inject comes into picture, main repository, as long as the app, so if you look at the app process, the app starts, main repository is still not in memory. It goes through Splash, main repository is not required because Splash, we aren't doing any check. We're just keeping it as is. Right? Now, when this guy comes, then this main view model will kick in. That's the whole point. Kick in as in it will get initialized and so forth.
Initialized, right.
Yes. And this is the key component. Basically, if you write this, you don't have to do any of this. Sorry, you don't have to write any of this. Sorry, my bad. Yeah, you don't have to do all that Android inject and, and you don't have to. You don't even have to do Dagger. Your component name,
component definite, right?
Yeah, you don't have to do any of those builder patterns and stuff. They've reduced it even further down. Like, even though I like that builder pattern, I like factory pattern, I like a lot of those design patterns. But especially when you're managing a big project, I think Hilt is going to really, really kick ass over there because you don't have to manage a lot of the stuffs there. So, yeah, I hope that answers your question.
Yes, yeah, it does.
Cool. Okay. All right. Lucky Jenny Motion is. Yeah, lately emulators have become a challenge.
What API level is this?
I think this is
looking at that search bar.
Yeah.
I think I started it's an Android 8, 26.
Oh. Then Jenny Motion needs to update their search.
Right. Looks more like Honeycomb and KitKat types.
Okay. In the meantime, if you want to discuss something else, we have that. We have that
one other
where the build is taking. Yeah.
Right. One other question that I had was, if you go back to your install with activity retained, this right, which we did. So we talked about the other way around, right? Wherein if it is, you have declared it as a singleton and then you try to reduce the scope, that will give you a compile time error. But now if I do the opposite here, you say install with activity retained component, but then I say add singleton on the provide main repository. What does that?
You'll actually get a compile time error because see, when you say install in, right, the component is the parent. The module is like a child. A parent can have multiple childs, correct? Right. And this component is literally defining the scope of child. So the whole mindset is that you keep all your singletons in a more generic format where you do something like this. All your singletons should be. So if you look at this, right, this particular graph, the table, they're literally enforcing you to do this now. So if you have a singleton component, you have to use a singleton dependency.
Right.
You can have
So it is
you can have like a scope. Yeah, sorry.
right. It is like a exact match, right? Like I was under the impression that just looking at this for the first time, right? I was under the impression if I do a single component, then I should be able to do activity retained because it is like nested scopes, right? Like singleton is the application level, but then activity is retained and view scoped. All of these are like a hierarchy kind of a thing, right?
I think that is where people struggle with Dagger, right? If you realize
Right.
from a mindset, right? If you're coming from like an example, hey, can I write? See, this is the singleton based class, correct? I'm
Correct.
putting it out there like that. But I can also do something like this, right? I can have something like my feature. I can
Exactly.
still
Right.
have some like provides. Again, I'm taking the example. Now, what will happen here is we can actually try this. Let's see if this compiles. We have. Okay. I'll just extract this guy out and delete this for now. It'll be easier to do this
Right.
than waiting for the compile to work. Oh, and also this fellow.
Yeah, you need my feature.
Okay, I'll just take this and read it. Name it as my feature. Yeah. Okay. So if I just hit build, so basically what they're trying to say is if you have a singleton component, correct? The component is not responsible to manage it for you now. You're not taking the benefit of a component. And also it should ideally say that this should not compile. Because you're literally saying, hey, all the things that are there in this component are singleton based. Meaning that this component should initialize with. So the whole point of this, so you've never seen this class before, correct? Singleton component.
Correct.
Singleton component is initialized in the application.onCreate. You wouldn't want a feature scoped kind of a thing initialized in the activity or the application on.
Right.
You would want it somewhere post fact. Yeah.
Right. And I think that's where currently it is most confusing for Dagger 2 as a end user for most people, right? Because there is nothing stopping me from doing this today, right?
Actually, I think this is what is stopping. it literally stopped. It's not stopping me in the correct.
Dagger 2, right? Like in Dagger 2, I could just go ahead and do this and it would still work the fine. Of course, your dependencies would be messed up. That is a different story. But then it would not do a compile time error or error at runtime of any sort.
Yeah, because see over there, what people see, I'll take you through that process as well. So what people would do is, let's say I don't use this, correct? Right, module. I'm just deleting that line for now, correct?
Right, and
you would have some
component, right?
Yeah, and you could have something like interface, core component, correct?
Correct. Fair enough.
And you can have persistence and all those things, correct?
Right.
You can have modules.
Dependencies, modules,
persistence, network. And people would write something like, like some example object which is of my feature.
Right.
Basically a feature scope. So the one is stopping you over there because you're in the driving seat. But with Hilt, even though you're in the driving seat, you also get that autonomy, like where the car autocorrects some of your functionalities. Like it literally say compile time errors like this. Like, hey, dude, so I don't know why Studio is not giving me the option to see the build logs instead of this build steps. For some reason, it's I don't know. Studio has been really difficult to work with lately. But if you look at just from this angle, let's build the project. Correct. Let's remove. Oops, sorry. Let's remove. Oh, sorry, my bad. Yeah.
Install it.
Sorry. Correct. Now, basically, if you realize the Kotlin syntax here, right? It's a class. Basically, we're giving it a class reference.
Right.
And install-in is basically saying, oh, I will do the magic behind it. I will create a class for you with a component which behaves in a single format and so forth. That's the whole point of it, right? So let's try and run it, at least get this build running once. I actually thought it's that miracle day where I hit run and it literally built for me. It didn't. Sorry, I think I'll have to just quickly change my headphones. Oh, one second, what is this? Oh, okay. I've done some repository module changes.
Yeah.
Can we go back? Oh, okay. Repository module has some example object which we no
Right.
longer provide. Yeah. Sorry, just give me a second. Oh, okay. Unfortunately, I haven't charged my AirPods. Sorry, unprepared. Let me just quickly change the.
That
speakers.
seems to be the common theme on the
Yeah.
show. Like Jitin came across us with his headphones not charged as well. So yeah.
There is audio. Yeah, let me just change. Am I still audible?
Yes, yes, sure. No.
Is this better?
Not exactly.
The volume too less?
Yes, yes, yes. That's
Right.
the problem.
Oh, okay. Yeah, Catalina, Mac OS 10. Is this better now?
Yeah.
Yeah.
I think the software is controlling, not controlling.
Oh.
Okay, I'll try and speak up loud. This is again one more problem with a lot of folks who stay away from foundation-based. You don't see what the hell the problem is. It literally doesn't give you the reason statement. And if you remember how to turn on the basically these basically these logs kind of disappear themselves after the fact.
Yeah.
The build. Wait, yeah. Array, but yeah, I'll just quickly just. I think just for the sake of argument, because we've been talking in words, but we're not showing like how exactly coping works.
Yes.
Basically, we have a list page, and then we have a right side. We have a so when you click on a Pokemon, you are taken to the. So basically, we want to control stuff like fact that hey, this particular details page should only control this dependency. So just by can apologize some weird reason. I'm not able to figure out what the error message is. But yeah, what we want to ensure is that we write the minimalistic possible dependency graph,
Right.
and at the end of the day, we get more simplified. So if you, unfortunately, there are a few tools like Scapboard, which gives you a very nice. People, have multi-monitor. So the Brave browser is always taken. There is something called Scrapboard by Arun.
Right.
Yeah.
Dependency graph, right?
Yeah, this gives you a very visual implementation of your own Dagger dependency. I think it's a spelling. Pretty sure it's
Exclamation G.
Am I getting the name? What did you say? Sorry.
Go to the front and type exclamation G and then scale.
Or I'll do it this way.
Yeah.
So basically, you can see it in like a proper graph of how things are.
Mm-hmm.
Yeah, basically this kind of a thing. So we want
Right.
we should not have a very complicated component like this. If we, I'm just taking it as an example. So entry point. So exactly this. So he's also converted his IntelliJ plugin. So basically, Scapboard is an IntelliJ plugin. He's
Right.
converted this to be more compatible with.
Okay.
We want these entry points which handle stuff for us. And we don't want these dispatching Android injectors. We don't want these
Right.
findings and stuff. So he's also covered kind of Android, Dagger.Android.
There's a similar tool called Diagraph.
Yeah,
Right.
Diagraph is basically more of a Node.js plugin
Yeah,
sitting in your terminal, and yeah, this is also very powerful. Sometimes people, I want like real-time change, right? This needs code to compile.
right.
Yeah, facing generic issue. So this basically gives you a graph like this. This is okay. I mean, this is not the most optimal dependencies, but if you look at
Right.
it, components, then there is subcomponents, then there are modules on the right, and so forth.
Right.
Correct. I know it's obscured the text, but then usually the components, modules, and then or maybe sorry, components, subcomponents, and modules.
Yeah.
This is still good, but imagine that this component depends on this component, and this subcomponent depends on some
Yeah.
different mess. So that's why I sometimes recommend folks in my talks that hey, do not use subcomponent because it's easy to build it on the first, but then later on you will not remember, or you will come into problem statements like there are. I'll probably link my slides for folks who are kind of curious.
Yeah. So.
There are a lot of those chances that your subcomponent knows too much about your component, and component depends on someone else as well.
Yeah.
You're unnecessarily wasting. I mean, this graph will look more like a proper hairnet. Just literally a girl putting all her hairs together and just even a gem. So
Yeah. I think you can post your source code on our Discord channel. Adit.
sure, I'll do that.
Yeah.
By the way, this
Cool.
is just the Pokédex. I've not done anything fancy on top. I've just taken this because when I tried my Dagger.Hilt, it was
Yeah.
I was that brave enough to try it.
Yeah.
I haven't yet.
Yeah.
What I'll do is I'll create a simple project without data binding and stuff.
Ha.
Very straightforward.
Right.
I'll create two branches where I have Dagger.Android, three for that matter. Like Killer Dagger, Dagger.Android, and you can compare.
Yeah.
That's about it. If you have any particular questions.
I think no. Do you have anything to ask, Adnan?
No. Should be fine for now.
Okay.
Cool.
Dagger is something that we can probably create for like 48 hours.
Yeah.
It's difficult to cover. I hope at least some points kind of resonate with
Yes.
viewers can obviously reach out.
Yeah.
Discord anyway, yeah, part of it.
Okay, so I think that's all for today, folks. Thanks for joining in. I'm going to close the stream.
Yeah. Thank you.
Thank you, Adit.